Good morning, my dear students. Hope all of you are very fine. I am Abbay Jyoti Pradhan. Today we will going to discuss some important topic about the acid, bases and the salt. So in the lower classes already you have learned about it. So if we go to the nature at first, then the taste of different citrus fruits like lemon, orange or grapes, tamarind, etc. they are sour in taste. So what is the reason behind it? Because they contain some organic acid. So due to the presence of some organic acid in the fruit, they taste sour. So we can say that acids are sour in taste, but bases are bitter in taste. And you know about the indicator. Indicator means the compound which change their color in the acidic and basic solution to show the nature of the solution, where it is acidic or basic. So there are so many indicators like litmus, phenolphthalein, methyl orange, methyl red, and that is natural turmeric, etc. So many are there. So the acid also and bases they change their color in no sorry the indicator they change their color in the acidic and the basic solution. Okay. So if we take just one example, the litmus they change their color in the acidic solution. What is it? The blue litmus change into the red in the acidic solution, and in the basic solution the red litmus turns into blue in color. So these are the basic idea. Now today we will discuss the Arrhenius concept of acid and bases and the chemical reactions of acid and bases. So actually there are different concepts given by different scientists are there. Just like Arrhenius, Longstep, Lewis concept, so many are there. But today we will discuss the Arrhenius concept. So Arrhenius told us that is acids are the hydrogenous compound which release H plus ion as a cation in the aqueous solution. Aqueous solution means the solution with water. But bases the release OH minus ion in the aqueous solution. Okay. So if you go to the example, different example, like HCl. HCl hydrogen is there and dissociate into H plus Cl minus. Chloride and H2SO4, they will dissociate it H plus and SO4 2 minus, and that is the CH3COOH, acetic acid is there. So it will dissociate into acetate ion CH3COO minus plus H plus. So these all are acid and these all are acid, these all contain H plus ion and they all are release H plus ion in the aqueous solution. So that is the criteria for being acid according to the Arrhenius. And if we go to the bases, then sodium hydroxide is a strong base. So Na plus and OH minus it will dissociate. Calcium hydroxide, that is the lime, and that is Ca2 plus and 2OH minus, and aluminum hydroxide that is present in our antacid, that is weak base. So Al3 plus 3OH minus. So see that here all the bases they release OH minus ion in the aqueous solution. So according to Arrhenius, the compound that release OH minus ion, that will be the bases. Okay. So now we will go to the different chemical properties. Different chemical properties of acids and bases. Okay. So here see that. So the first chemical properties is a reaction of metals. Reaction of metals with acids and bases. The reaction with metals. Okay. See that. So at first we will discuss about the reaction of acid with metal. Okay. The reaction of acids with metals. See that. So here the common general reaction is that is metal plus acid, that will salt plus hydrogen gas is there. So if we go to the example, that is a metal, if we take that is zinc is a metal, and any acid like hydrochloric acid or sulfuric acid if we take, then the salt, that is ZnCl2, here the zinc will displace the hydrogen from the HCl, and the zinc will combine with the chloride ion, then the zinc chloride, that is a salt, is produced, and that hydrogen gas will be produced here. So if we balance it, then 2 will be there. So here is another thing, how can we understood the which metal will react with acid to produce hydrogen gas, and which metal will not react with acid to produce the hydrogen gas. So here is the metal reactivity series. If we know it and if we learn it by considering the metal reactivity series, then it is better for us. So now I am writing it in the right side. Okay, see that. So that is the metal reactivity series. At first potassium is there, and then sodium, calcium, then magnesium, aluminum, zinc, iron, tin, lead, and then the hydrogen, although it is a non-metal, but we will write it hydrogen. After that Cu, Ag mercury, Ag silver, after that Au gold, and platinum. So here we can divide the metal, or we can classify the metal into the two groups. So the metal, that is the position of hydrogen here is important. The metal that present above the hydrogen, and the metal they present below the hydrogen. Okay. So here all of you know about the displacement reaction in the first chapter. So here the metal present in above the hydrogen, like potassium to lead. So they can displace the hydrogen from the acid to produce the hydrogen gas. But the metal they lies below the hydrogen, like copper to platinum, they are unable to displace hydrogen from the acid to produce the hydrogen gas. So if we go to the example again, see that. So any metal like magnesium, aluminium, they can take magnesium plus sulfuric acid H2SO4. So see that magnesium present, that is above the hydrogen in the reactivity series. So in the reactivity series, the metal they lie above the hydrogen, they can displace the hydrogen gas. Okay, because they are more reactive metal. You know, in the metal reactivity, in the displacement reaction, that is more reactive metal can displace the low reactive metal. Although hydrogen is non-metal, you can consider it here. Okay, so magnesium present above the hydrogen, so it will displace hydrogen. Then magnesium will combine with sulfate to produce a salt, MgSO4 plus hydrogen H2. Hydrogen gas will be there. You can take any metal from here, like aluminium also you can take aluminium plus HCl. So that, see that aluminium also present above the hydrogen. So that is aluminium will combine with chlorine, that will aluminium chloride plus, that is H2 gas will be produced here. Okay. So then, but this metal like gold, platinum, they are like silver, they present below the hydrogen in the metal reactivity series. They are unable to displace hydrogen from the acid to produce the hydrogen gas. Okay. And copper, mercury, this metal, okay, they cannot displace hydrogen from acid. From acids. Okay. So here another thing is there, the reaction of another acid, nitric acid, that is little bit different with metals. Okay, now I am writing here. See that in case of nitric acid, the reaction of HNO3 with metals. So here the general form is metal plus HNO3, that will be, see that nitrate salt will be there, nitrate salt will be there, plus nitrogenous oxide will be here, nitrogenous oxide and water, nitrogen oxide, and what are the oxide, like NO2, NO and N2O plus water will be produced. So here NO2 nitrogen dioxide, NO nitric oxide and N2O nitrous oxide depend on the concentration of HNO3, that is nitrogen dioxide, NO and nitric oxide and nitrous oxide will be produced. If we take concentrated HNO3, then that will NO2 will be produced. If we take dilute HNO3, then N2 will be produced, and if we take a medium concentrated, just like 40%, 50% HNO3, then NO will be produced. So here one more thing, see that here hydrogen gas will not produce. In place of hydrogen gas, water will be produced. So what is the reason behind it? Because HNO3 is a strong oxidizing agent. You would know about it, that is oxidation and reaction in the first chapter. So as HNO3 is a strong oxidizing agent, it will oxidize the hydrogen gas to the water. So here hydrogen gas will not produce. Here in place of hydrogen gas, water will be produced, because the strong oxidizing HNO3 that will convert or oxidize hydrogen to the water. So here if we take just one example, like metal, like if we take the zinc plus HNO3, then the salt, that is the zinc nitrate, ZnNO3 or 2 plus, depending on the concentration. If we take the concentrated HNO3 and concentrated and hot, okay, then that will be NO2 will be produced here, that will NO2 plus water will be produced here. Okay, so if we balance it, there is 4 and that is 2 and that is 2. So these are the common reaction. So very few metal like the magnesium and the manganese, they produce hydrogen gas with the very dilute HNO3. Okay, so that I am writing now. Yes. So these are the common format. So very few metal like the magnesium and manganese can produce hydrogen with dilute, very dilute HNO3. As for example, you can write that is magnesium plus HNO3, very dilute HNO3, that is magnesium nitrate, that is the nitrate salt, plus hydrogen gas should be produced here. Okay, and now we will discuss about the reaction of metal with the bases. So only very few metal like the amphoteric metal like the zinc, aluminium, tin, etc. So they can react with the concentrated base like NaOH and KOH to produce salt and hydrogen gas. So here now we'll discuss the reaction of bases with metals. Reaction of bases with metals. So here only few metals like the zinc and aluminium only. Zinc, aluminium, tin, etc. they can produce. So here that zinc plus NaOH. That is the concentrated aqueous solution. And if we heat it, then the salt will be produced. That is Na2, ZnO2, sodium zincate plus hydrogen gas will be there. So that is the metal plus base, that is the salt, sodium zincate, and hydrogen gas will be produced. And in case of aluminium also, so that will be react with NaOH plus here water will be required here, that will be sodium aluminate, that is also another salt, plus hydrogen gas will be produced. So only very few metal like zinc, aluminium, tin, so they react with strong alkali like NaOH and KOH, and concentrated aqueous solution of strong alkali. Okay, and then if we heat it with the solution, then they will react to produce salt and hydrogen gas. Okay, so if we balance the reaction, then that will be, I think, 2 hydrogen, and that will be, the 2 is there, and here 2, there is also 2, and here you are writing 2, and here you are writing 3. Okay, let me check. Okay. So that's it, and thank you very much for the topic.